Hello, my name is Elliot Yu. I'm 15 years old and currently in the 10th grade in Da Vinci Design, and this is my presentation of learning for math and chemistry. First up is math. This is my homework completion chart, and as you can see, I unfortunately did not complete all of my homework. I understood it, but there were just some instances where I would forget to do it or forget to turn it in. I checked my answers with other friends and also by looking on the DP, and I asked for clarifications from both Ms. Casillas and other students and friends of mine that knew the information better than I did. Underneath that is my assessment score chart. I did all my corrections except for one of them in early October, and I completed these questions by going back through the tests and resolving the equation and then comparing the two and seeing what I had gotten wrong in terms of math or what equation I used. And I also asked for clarifications and explanations from both friends and classmates. This semester, to improve my grade, I started working in a more study group type of environment, and I also got example problems from the DP and from other online sources, and different explanations from other people or for places like YouTube videos from Khan Academy. The essential skill and learning target I performed lowest in this semester is essential skill 2, similarity, and learning target 2.1. What I didn't understand about this learning target and essential skill is I would constantly mix up angles and sides, and while they weren't very major mistakes, they were mistakes that cost me really easy points. This is my original quiz problem, and this is my original test problem. For the quiz, I did not have the original corrections. What I had gotten wrong on the quiz was it had asked for angles and sides, but I only gave an answer for the sides. And what I had gotten wrong on the test was I got the question right, but I had gotten the justification wrong. So where I said it had all congruent sides, I should have said it had no congruent sides. And these are my test corrections for the test. In the second quiz problem and test problem, they were both ones that I had actually gotten right. And I had gotten these questions right because they were something I had, in terms of working with finding the number for angles and the justification, it was something I had practiced more with and gotten more explanations with and just worked more with. The current grade I have in this class is an A-, and the grade I think I deserve is, well, an A-. I turned in my work on time, except for some instances where I had scored low on something or just forgot to do something. So I think the grade I have now does reflect the work that I have put forward, and I can't really argue for a different grade, because if I deserve that grade, I would have it. And now I will be moving on to chemistry. The unit I'll be presenting on is Unit 1 of gases, and the first of the 5 subsections is random molecular motion. Random molecular motion is when there's no set movement in the way that molecules move. In solids, molecules will vibrate, but overall keep their shape until it becomes hot enough to turn into a liquid, where it has more molecular movement than a solid, but not as much as a gas, which has the most. And there's also no molecular movement at absolute zero, because at absolute zero there is no movement. Second is the combined gas law. For this, it is applying gas laws to reactions between the pressure, temperature, and volume of any amount of an ideal gas or mixture of ideal gases. For this section, we use this equation, which is P1V1 over T1 equals P2V2 over T2. An example problem for this from the test is a gas occupies a volume of 500 milliliters at a pressure of 380 torr and a temperature of 290 Kelvin. At what temperature would the gas occupy a volume of 1000 milliliters and have a pressure of 760 torr? For this equation, our initial pressure is 380 torr, our initial volume is 500 milliliters, and our initial temperature is 298 Kelvin. And for this, when we get numbers or temperatures, if we were given a number in Celsius, we would have to convert it to Kelvin, but because the number's already in Kelvin, we don't have to worry about it. Our final pressure is 760 torr, and our final volume is 1000 milliliters, and we are solving for the final temperature. So with our equation P1V1 over T1 equals P2V2 over T2, we just plug in what we have. So we have 380 torr times 500 milliliters over 298 Kelvin equals 1000 milliliters times 760 torr over T2. And because of the way the equation is set up, we want to get the T2 on the top, so we cross multiply, and our equation looks like this. And then, because we still want to isolate the T2, we're going to divide by 380 torr and 500 milliliters on that side, and then divide by that on the other side. And we're already starting to cancel out measurements that belong to the same, so the 1000 and the 760 will lose their measurements, and we'll just be left with the Kelvin, which is what we want because we're solving for the temperature. So after we've moved around all our stuff, we can just multiply all the numbers on the top and all the numbers on the bottom. So we have 226,480,000 Kelvin over 190,000, and then divide the top number by the bottom, and our final temperature is 1192 Kelvin. And then our third section is standard temperature and pressure. So for this, the standard temperature we would use is 0 degrees Celsius or 273 Kelvin. And our standard pressure would be 1 atmosphere equals 760 torr or 760 mmHg. At STP, ideal gases all have the same molar volume and take up the same amount of space, which is 22.4 liters of space for every 1 mole there is. And next is our Celsius and Kelvin temperature scales. The Celsius temperature scale is very easy to understand because 0 degrees Celsius is set at the freezing point of water, and 100 degrees Celsius is set at the boiling point of water. Now, the Kelvin temperature scale is different because it's considered an absolute temperature scale. So for this, the freezing point of water, or 0 degrees Celsius, would actually be 273 Kelvin, and the boiling point would be 373 Kelvin. And because it's an absolute temperature scale, 0 equals 0, so unlike a Celsius, you won't be able to go into negatives. And to convert between the two, you take whatever number Celsius you have and add 273 Kelvin. And to convert from Kelvin to Celsius, you take whatever number Kelvin you have and subtract 273. And our last section is the ideal gas law, which is solving problems using the ideal gas law in the form of Fibner, or pressure times volume equals the number of moles times the constant times the temperature. So another example problem we have from the test is how many moles of gas would be needed in a 4-liter boat piston to create 10 atmospheres of pressure if the piston reaches the temperature of 400 Kelvin. So the pressure we have is 10 atmospheres, our volume is 4 liters, the constant in this case we would be using is 0.0821, and the number of moles is what we were solving for, and our temperature is 400 Kelvin. So we have Fibner, and then we plug in everything we have. And already here you can see we're starting to cancel out materials or measurements that belong to the same category. And then because we're trying to isolate the end, we divide both sides by the 0.0821 and the 400. And we again are starting to cancel out like measurements. So we're left with 10 times 4 over 0.0821 moles times 400. And because we're solving for the moles, we have the right measurement we want. We multiply the top and the bottom. We have 400 over 32.8 moles. And the top divided by the bottom is, our number of moles is 1.2. And with that rush explanation, I conclude the chemistry and presenting part. Thank you for listening. Get Photoshop your face on it. Thank you so much.